What we're talking about now is how to measure the strength of an electric field. We've already talked about how to draw it, but now we actually want to measure the strength. And what we're looking for is, it's an amount of force. Remember, we're pushing charges around. And to push charges, you need force. So it's an amount of force that would be exerted on 1 coulomb of charge placed at a specific point. That's going to be important. In an electric field. Maybe you're already thinking about why a specific point is important, but we'll get to that in a second. And the formula is, not too crazy, you can think of it as the electrostatic force per coulomb of charge. Okay? In this case, this Q is the charge that is experiencing the force. Gonna have to keep track of that. Later on, we're going to have another formula, and that Q is going to be something different. Force is in newtons, charge is in coulombs, so the units for electric field strength are the newton per coulomb. So let's do a quick example. See if you're getting this. How strong is an electric field? If an electron feels a force of 12 newtons in it. I'm pausing just for a second for you to start writing and maybe doing this problem. Of course, as we're getting ready for the Regents, we want to remember we always start by writing the formula. Then we substitute in including units. Okay? These little things might seem annoying. It's a lot more annoying if we're going to lose points because we don't do it. We know the force is 12 newtons. What's the charge of 1 electron? I don't know if that's a little mean. Hopefully it's just a reminder. 1 electron is an elementary charge. 1 elementary charge is 1.6 times 10 to the negative 19th coulombs. What do you get as an answer? You grab your calculator. Doesn't take too long, hopefully. 12 divided by 1.6 times 10 to the negative 19th. 7.5 times 10 to the 19th newtons per coulomb. Now we're practicing the math a little bit. That's great. Now if you remember from the previous page, it's the amount of force that 1 coulomb of charge will feel when placed at a specific point. Why is it a specific point? Because we know that force changes. Electrostatic force changes. How? We've got Coulomb's law to remind us. These charges in an electric field, at least for our example, aren't going to change. One of them is the electron or whatever is in the field, and one is the charge that creates the field. So in the only way, if these two things don't change, what's the only way that the electrostatic force is going to change? If you change a specific point, it's all about the distance. Now, a typical physics thing to do is take a bunch of formulas and merge them together to see something new. So we can take this formula, our basic electric field formula, substitute this in for force. I'm not going to do all the math. I guess maybe I will. One of these Q's cancels out, and you've got an alternative formula that says the electric field can be found this way. In this case, this is the Q, this is the charge that is creating the field. It doesn't matter what the other charge is, because the electric field is the force per charge. So this is going to tell you what the force per charge is, and if you know the other charge, it's all going to work out. Let's do one example. Find the E, 8 meters from a 45, I'm going to use a small number, microcoulomb charge. Again, I'm going to give you, 7 seconds to practice to see if you can get started on this ahead of me. Hopefully you're trying. We know K from our reference table, 8.99. It's okay to round. 9 times 10 to the 9th, a whole bunch of units that are going to mostly go away. Our charge creator is 45 microcoulombs. Squared. So what you get at the end here, grabbing our calculator one more time, (6,328.125) newtons per coulomb. I don't know if that's a pretty number or not a pretty number, but it's the number we want. Couple of big ideas about calculating electric field, a couple different ways. The reminder to be creative in how you solve for other formulas and how that can be helpful, and hopefully this will make some good sense for you.